Last week we covered some of the available database platforms and had a basic introduction to Postgres and pgadmin. Today we're going to be looking into initial config of the database server and some more stuff. So before we actually get started properly this week, I'm going to pass around this sheet of paper, and I'd like you guys to fill it out with your name, your university email address, and the operating system that there's going to be running on the laptops you're bringing to the workshops. And this is so that I can get you guys set up with users to the sandbox, so that you can have access to the actual database during these sessions, and you can run stuff while I'm talking and actually play with it.
Right, no laptop, so I'm just going to watch this.
Cool. Do you have a PC at home?
No.
Cool.
Oh, a PC is fine. Something else. Yeah, I have a PC.
Okay. What I can do is I can also set you up with sandbox access outside of the workshops, because at the moment it's only open during this hour slot. Right. So I can still give you the details, and you can try out queries after the session's finished, if you like. Cool. So a brief reminder of where we had reached. We're now on the part of initial configuration. So we're going to be delving into a little bit more about the actual setting up a server from after you first installed it, and permissions and all sorts of other things. So we had connected to the database server with the Postgres super user, and that was confirmed running nicely. We're going to talk a little bit more about roles and permissions and basically access control. Going to cover the creation of a new user and a new group. And then some common table structures before we delve into transactions and ACID. Not the good kind. I didn't have time to touch on creating databases last week, but it is relatively trivial. In almost every platform, the only command you need is create database and then the name of the database. Job done, that's it. The user that you run that command as must have the privilege to create databases in the first place. If they don't, obviously, it's not going to work. So typically speaking, you'll see people use the super user to do that, because the super user has unquestioned access. So it'll automatically have the privilege. So just to test this out, I'm going to very, very quickly dive over to pgadmin and create us a database. So I'm logged into our installation demo server we were playing with last week. I'm going to open a connection to the Postgres database. I'm logged in as the Postgres user. Come on. Yes, yes. Okay, so a little bit better than last week. It actually shows you something decent. So you can see we're connected as the Postgres user. That's that there. And that's the name of the database server. So what we're going to do is we're going to create database, and then we're just going to call it workshop test, because I'm feeling incredibly inventive. Semicolon, and then you can hit the play button to run the query. You can hit F5. Does the same thing. So there you go, new database in about a second. Job done. Obviously, there's a lot more you can do with that command, and I'm going to take this opportunity to show you how to read the Postgres online documentation. I'm hoping that this skill will be particularly useful for you guys that will help you out of a bind. If you ever have to look up a command, or if you're ever unsure, documentation is a perfect place to look for these sorts of things. So changing to the version we're using, let's make the text a bit bigger, there we go. So start off, anything that's compulsory with these commands will be shown just as is in plain text. So those parts are compulsory. Anything that's optional is shown in square brackets. So as you remember, I just ran create database with the name and it did it. If I wanted to, I could set an owner to be a particular owner. In our case, it was Postgres, because that's the user we were using. And various other things like a table space, which I don't think I'm going to have time to go into, and connection limits and the like. So essentially, this is quite a simple example. You'll see anything that's in italics here is a variable, which is usually explained further down here. So there's the name of the database, the username, which is highlighted, and various other things. So it explains the values the parameters will accept. So essentially, if you get stuck with any SQL or command for the database, go straight to the documentation. It will tell you exactly what's going on. So moving on. Just like with operating systems, users and groups are incredibly important, and they play a crucial role in database servers. Almost all databases will provide you very, very fine-grained control of user permissions, which dictates obviously what users can and can't do to various objects within the database and also within the server itself. So here are some examples of what you can control. You've got operations like select, which is read-only, insert, update, delete, which are read-write, and various other things as well. So not just tables and columns, but you can apply these things to functions, to sequences, all sorts. Literally, if there is an object in the database, there is a high probability that you can tell someone what they can and can't do with it. So what I'm going to go into is not the be-all and end-all of permissions, certainly not. And if you're interested, I encourage you to look into it yourself. I don't have time to cover everything, I'm afraid. So here are the basics to start with. So you can use the keywords grant and revoke to give or remove privileges from a user or a group on various objects like tables, columns within tables, schemas, that sort of thing. You can even allow or deny users logging into the system. So where it says here, access login, it's not showing my cursor, boo. Essentially, when you create a user, you can say whether that user is allowed to log in or not. So in the past few moments, I've been referring to these as users and groups because there is you have to distinguish between them when you're thinking of control over the database and how you're controlling things. To Postgres, they are all what's known as a role object. Yeah. So to Postgres, there's no difference between a user and a group. A role is a role. It could be a single role or it could be a collection of roles. Fellas, if you just want to note your details down on that list there for me, please. So in the world of permissions administration and user rights, there is a general global convention or consensus, which is when you choose to assign permissions to something, you should always assign those permissions to a group. Anyone want to tell me why? You don't have to. No? Okay. The reason for doing that is that if you need those same permissions to apply to another user in the future that you haven't yet created, all you have to do is stick them in that group, and their permissions are inherited from the group. That inheritance, actually, as the second point says, is something else you can control. So you can dictate whether a group's permissions will flow down to users in that group. We'll talk more a bit about permissions inheritance later. There are different areas where you can set permissions for a role. You can set it on the role object itself. Those are things like superuser, login, as mentioned, and there are objects such as tables and databases and schemas, which is where it's not necessarily an attribute of the user, it's more about what they can and can't do. So if you really wanted to, you could let a user log in, but sadistically say, you can't use any tables, and they can just log in, that's it. It's a bit pointless, but it's funny. So there are role permissions and then there are permissions within the database. So users will be global across the entire database, but the permissions on objects vary from individual database to database. So if you have, very quickly, if we look at pgadmin, we've got two databases here which I've created. There's one called privilege demo, which we'll see later, and one called structure demo, which we'll also see later. You can assign different permissions for the same user within each of these databases. That's the upside, is you've got the flexibility. The downside is if you want them to have equal access across all databases, you've got to run that same script across each database. So take the good with the bad. Come here. So there are, as I said, I would encourage you to look into these if you're interested. There is a huge amount that you can do, which I simply cannot capture in these workshops. Absolutely huge. But for the purposes of demonstrations, we're going to create a new user called Sarah. Sarah is going to belong to a group called plain users. And this group is going to have almost complete control over our database, privilege demo, with the exception of one table, our super secret table. We're going to grant all privileges, that's the keyword, to the group, but we're also going to revoke all privileges on a particular table. So let's set ourselves up to create these roles. I'm going to jump over to pgadmin. How visible is the query text? Is it good size, bad size? Meh? OS 10 zooming. That's clearly not working. Okay. This is where pgadmin starts to let me down. Query editor. Come on. Oh no. No, no, no. Please. Ah. Bah. So while that's powdering its nose, oh, come on. Right. Go hard or go home, right? Perfect. So, remember I mentioned there are only technically role objects that pertain to users and groups? That is still true, but there is a specific command to create a user versus actually just creating a role. It sets up some useful options for us which link into actual users, so there is a relevance for having it. So the create user command automatically grants that role the right to log into the database server. Whereas if you're just creating a role, you might not want it to log in. For instance, the group that we're going to create, plain users, is not going to have the right to log in because you can't necessarily log in as a group. So we're going to begin with the command to create the role for Sarah's user, and we do this by stating that we want to create the role and then giving it the name. So we're going to specifically also mention the no login option. So what I'm going to type here is create role plain users no login. If I could spell. Amazing. What this is going to do is this is going to go and create a role for us, which we're later going to populate with other roles, which are going to be our users. So, write database, yes, run. Ooh. Oh, sorry. With no login. Herped up. Play nicely. Okay, never code live. So we don't want that group to be able to log in. That's why we set it as no login when creating the role. Now that we've created that, we can move on to creating the actual user role itself for Sarah. So we're going to specify this by create user instead of create role. Why is this so slow? And then we're going to say with password, and then we're going to give it a password. With password specifies that a plain text password is going to follow, which will then be encrypted by the database. So we're just going to call it, I don't know, Sarah Rocks. This is where a unique or useful feature of pgadmin comes in. When you go to run in most query editors, it will only run selected text. So if I hit F5, it's just going to create that role as the user. Now, that's created the user for us, and that user is going to be able to log in, but that user is not yet a member of the group. There are two ways you can do this. You can specify it at create time, or you can do it through an alter role. So, or rather, not an alter role, but a grant. So, because I've done this the wrong way around, I'm going to say grant plain users to Sarah. And now Sarah is a member of the plain users group. If you want to check this out, within the Postgres database and under a certain schema, you can see all of the roles in the database. So if we go pgcatalog.pg, I think it's roles. When we're connected to the right database, we have to switch to the Postgres database to be able to run that query. Okay, so we can see we've got various, as I said, they're just roles. So that's a group, that's a role, that's a role, that's a role. They're all roles, but some are users, some are groups. You've got password and then various Boolean values dictating what they can do. As you can see, Postgres being the almighty super user can do literally everything. Plain users don't get too much. You can see role inherit is true, and that allows what we're about to do to work. So we're going to very, very quickly set the permissions that we need to. Within this database, there are two tables. There's a table called open and there's a table called super secret. I do have to switch back. So you can see here, we've got some rows, just some basic text, nothing too fancy. Come on. But we can also, we're at the super user level at the moment, so we can see everything in the database. We don't want those plain users to see what's in our super secret table. I'm going to be lazy and use autocomplete.
Does it do that automatically?
The highlighting?
No, they just like to be typed in lowercase.
Yes, it does because I've set it to. It's not on by default.
Just preferences,
So in our super secret table, we've got things that not everyone should be allowed to see. So this is actually a real-life situation. If you've got information on customers' accounts that you only want certain members of your staff to be able to see, you're going to want to control that very carefully to make sure that everyone has access to the right data. Otherwise, you could be breaking laws and all sorts of nasty things. So what we're going to do is we're now going to do those two operations which I mentioned. So we're going to grant all privileges to plain users on all tables in schema, I think. And then specifying the schema of public. When you create a database in Postgres, it creates a default schema for you called public. Space. Thank you, caps lock. If we hadn't... If we hadn't run this command, then Sarah would not be able to do anything at all, because we haven't specifically stated that she has access to the database. As I said last week to do with the connection configuration, Postgres will start in a very, very secure state, and you have to lessen the security with the more flexibility that you require. So this command here is going to let us run, or let us give those privileges to those normal users. But we have to be very careful that we want to hide the data in that super secret table. So we're going to say revoke all privileges on here.
Can you also say on line 5 to Sarah?
Yes, you can. Because this here is a role object, it doesn't matter whether it's a group or a user. It's going to get given those permissions. So you could, but as I mentioned earlier, for the ease of administration, you usually want to have it as a group. So you could, if someone new starts your company in a particular job, you say, you need access to these tables. I'll just add you to this group, and it's all done. You've done all of the hard work previously when you set the groups up in the first place. So we're going to now revoke the rights of Sarah on the super secret table. Rather, in this case, plain users, because again, we're doing it at the group level. And that's going to deny access to any privilege or any query whatsoever, select, update, insert, not going to allow it. Assuming my syntax is correct. There we go. So now what we need to do is we need to connect to this database as our new user, Sarah. What 83. Username is Sarah. Come on, behave. And the password, if you recall, I think was Sarah Rocks, something unimaginative. Okay. So here it is. There's our new connection. We're connected as Sarah. So we've already been able to log in. That's that part tested. And now we're going to connect to the privileged demo database. So we're now connected. So if I then run this same query again, select all from open,
So is that just like a
oops,
virtual user?
typo.
Or an actual user?
What do you mean by virtual?
See the way you had their IP address?
Yes, that is an IP address. That's a user within only the database. It's not a user on the operating system. So we can see everything in the open table, but if we try and select from the secret table, it won't. At least I hope not. This is the proof in the pudding. We should get access denied. Perfect. So we've been able to grant the permissions to that particular group, and Sarah is an example user in that group. If we were to add another user, they would get exactly the same rights as long as they're set to inherit. And that's the key point, is that if you have a group with permissions and that user doesn't have any of those permissions in place, it will automatically inherit from the group above. To demonstrate this point, I can give Sarah the privilege to just select from that table, but all other rights will be as per the group. So if we say grant select on table super secret to Sarah, what this will do is it will override that inherited permission from the group, allowing Sarah to see what's in the table. So now if we go back to our proper window as Sarah, well, hey, we can see what's in the table. Job done. So that's a small subset of what you can do with permissions, a little bit of the flexibility of it, and hopefully what you'll take away is that structure of create the group, put users in the group, give the permissions to the group. When you're doing this in practice, so if you've got an existing database that you need to change the permissions for, and you're going to have users coming along on a regular basis, you're going to want to put all of these necessary commands in a script that you can save and run as and when you need to. That will make your life a lot easier than saying, what table was it they needed, and having to look up every single one. So just a tip for you there. That's permissions effectively in a very, very small nutshell. Oh dear, I have some slides. Next is table structures. I'm going to go over briefly some of the very, very common structures of tables that you see in databases, particularly in running systems. This is going to take quite a different approach to what you might have seen in the lectures. Have you covered normal forms yet? Okay. That was a very high-level theoretical overview. So they mentioned TED, COD, and IBM, and all sorts of other things. I'm going to focus specifically on third normal form because it usually provides the best balance between being anal about how relational your information is and actually having a working system that doesn't cause everyone a headache. So sometimes in order for a system to be functional and performant, it's not always possible to maintain third normal form. For those in doubt, just in case you're not familiar, third normal form can be colloquially summarized as every non-key attribute must provide a fact about the key, the whole key, and nothing but the key. In this case, the key is a single or a set of attributes that defines a particular row in that table. It could be an ID column, it could be a set of columns. It's up to you as a designer. You may also have been told to never ever store data that you can calculate. Have you been told that?
No.
It's another one of those things whereby it's nice in theory, not good in practice. So, for instance, if you say you have a table detailing all of the orders that everyone has placed ever across all of your customers, and you say, I want a running total of this customer's account to date, you could run a query that would calculate and sum up all of the order balances that that customer has put through. And that's calculating the information. But if your order table is massive and that query is going to take a long time, and someone's going to keep refreshing the page and it's going to run that query every time, you're going to want to store that result so that you're not taxing your database and so it's got better things to do. I'll go into a bit more detail about that in a moment. So that's essentially the reason for doing that. I speak from having worked in the telecoms industry. Every time you make a phone call, every time you send an SMS, and for every 6 kilobytes of data your phone sends, it generates a record. And on one of our databases, we had 10 million of these records in a single table. So if you, for instance, you wanted to sum up how many minutes of calls a customer had, and if you think about it, that's quite a common operation to check your bundles, you're not going to want to do that every single time, because your database is going to catch fire and it's going to fall over and it'll take everything with it. So what we did is we had a summary table that was updated by a job that ran either every day, every night, and that would update those summary values. So when you see things like the student portals say, oh, our data's 24 hours behind, that's because it's pulling data outside of a live database and storing it somewhere else. I'd like to make a distinction between the various definitions of key. As I'm sure you know, every table should have a primary key, which, as I said earlier, identifies the record in the table. That's, I think, a minimum of second normal form. Should be. You can also have what's called a composite key. A composite key is, as I mentioned, when you have more than one attribute as the key for a table. These are not particularly common in practice. Let's face it, us developers are lazy, so we're just going to say, you know what, give it an ID, be done with it. That's usually what happens. To ensure, as I said, to ensure simplicity, that's what they will do. And the auto-numbering is handled by the database. When you've used Access, I'm sure you'll remember it saying, you haven't got a primary key, and it will force you to create one. But in Postgres, it is actually possible to create tables without keys because it will assume that you know what you're doing. The reason for this is if you do want to create a composite key, then you can specify it explicitly and say, this is the key for the table. It's not just some Ponzi ID that I've pulled out from nowhere. I don't think we have time at the moment to explore how to set those keys up in table creation. I will put a video up on the playlist if you guys want to look into it. I would suggest you do. That should be up before next week's session. So I've, again, done a little bit of background work and created some tables in a demo database, and that will attempt to show the 3 types of relations, which are one-to-one, one-to-many, and many-to-many. One-to-one is generally quite uncommon, just because of how data is structured and how it behaves. The most common you tend to see is at least one-to-many or many-to-many. You might have heard many-to-many referred to as a join table. Yes? No? Maybe? Okay. So we have a few tables. Let's just go have a look at our incredibly slow query editor. This time we're going to jump onto the structure demo database. And we have a bunch of tables, actually. First off is one-to-one. And a common construct you'll see, without a colon, a common construct you'll see is to separate customer information from addresses. I'm fairly sure that's one of the demonstrated things in the lectures. So here we've got some basic customer information, a few entries, and you can see we've got that column just slightly to the right there called address ID. I'm assuming you guys have already worked out that we have a table called address that's got that foreign key in it, but using that ID as its primary key. With me so far? Cool. So we're going to then look into the address table, and you will see, if I hit the right key, you will see those corresponding IDs will have an entry in this table. Okay, so we've got address field 1, address field 2, postcode, and so on and so forth. And there's that primary key which we're referencing from the customer table. That keyword is particularly important because it means something special to Postgres. You'll see mention of that in the table creation video that I'm going to make. So this one-to-one relation is really, really simple to query. It's just one join. If we start with the customer table, wow, this is taking forever. There's one field that you're joining on from or between both tables. Come on. And then we have a result set. So really, really simple. This could potentially be a one-to-many relation, depending on whether you look for existing addresses before creating customers in this specific case, but it's intended as a one-to-one. Next up, we've got one-to-many, and we have two tables. We've got product and product type. As you can probably work out, a product can belong to a product type, so that's the one-to-many part, and the product type can have many products belonging to it. So here, we've just got some fairly basic categories. Just essentially, the information is just a description, and then the products themselves, again, just an ID and a description, effectively. This uses the same type of join as we've seen above. If I've remembered that correctly. Oh, this is so slow. Right, there we go. Okay, job done. Very, very simple. What you'll notice here is that because we've got a one-to-many relation, you've got the same value appearing against different unique products. So our golden Death Star is both Death Stars are interplanetary destroyers, for instance. Same thing goes for AK-47s, washing machine of death, blenders, so forth. So that's where you will have this particular relation type applies to categories, or where you've got a more generic container for specific objects like this. Finally, we'll go to the join table, also known as the many-to-many relation. We're using the same product table, except we've got a category table as well and product categories. So if we have a look at the available categories, I apologize in advance because this is many-to-many relations produce the messiest results set. The reason for this is that the join table, each record in the join table is a link between the two other tables. So for every record you have in the join table, you're going to have at least one record in your final result set. So here are the categories that we can apply to various products. Again, very similar to product type, except unlike product type, a category can have many products, and a product can belong to many categories. So the join for this one is a little different. Thanks, PG admin. Ignore the fact that you're missing the first column of characters. It seems to do that. So what we're going to do is select all, and I'm going to put the query on a new line to make it a little bit easier to recognize. From product, P, join product, if I can remember. Come on. God, that's mighty slow. This is the bit where it falls over and doesn't work, after spending ages to write out the query. Don't. If in doubt, underscore. Don't take that advice, by the way, I'm just being facetious. Okay, we've got a results set back. As I said, this is going to be messy. Because you've got various different memberships, you'll list every single membership for every single object. So your Golden Death Star is both a weapon of international warfare and a tool for home improvement, just as an example. Because why not? If you were to do this in a web application, you would have to parse this data quite carefully to bring out the right categories. Okay, so that's the many-to-many relation. Again, one-to-many and many-to-many are the most common that you'll see in databases that actually have running systems in front of them. So we have some time to delve into the very, very fun world of ACID and transactions. So these, I know that you haven't done these yet in the lectures. These will pop in the very last few, but I'm going to give you a head start. The ACID principles underpin essentially any database that uses SQL. Any of the Ponzi NoSQL databases like MongoDB, all of that lot, which I don't care about, they don't use these, which is partly how they claim to be so fast. The ACID principles essentially are what make databases so useful. And the acronym itself stands for atomicity, consistency, isolation, and durability. Atomicity essentially is also known as the all or nothing principle. What this means is that the database has to work in atomic units, and it has to complete that work entirely, or it doesn't complete it at all. So you have large table, 100,000 rows, and you just ran an update statement on it. You forgot to put where on that statement, so that statement is updating every single row of that table. Fortunately, you have time to stop it before it finishes, and that's the important part. While a query is running, if you hit stop, the database has to go back, undo anything that it's done, and return the data to the previous state. That is where atomicity is so important. So if you notice a screw-up and you stop a query from running, the database has to undo anything it's done. If, however, you're not quite fast enough and the query completes, then that's it. Sorry. Unless you're in a transaction, but more about that later. Consistency is the database has to transition between consistent states. What's meant by that is it's more internal to how the database works itself. And you may, I don't think you did, but you may have seen when an error came up in PG admin, it had state in the error message. That's essentially what that refers to. You don't have to worry about it too much as a developer using a database, you just have to know it's there. Isolation is another fantastically useful feature of databases, and when I mentioned transactions, that's what those pertain to. So isolation, if a database is well isolated, any operations that users are doing are kept separate from one another, and they should not interact. This means that you can have some idiot doing something in a transaction who wipes out half of your database, whereas it's still there for your other users because those queries and those effects are isolated from everything else. And finally, we've got durability, which is the database takes measures and steps to prevent against data corruption. Data corruption over time is a thing that does happen, believe it or not. We don't tend to experience it too much in day-to-day lives because our data changes so frequently. If you left your data on a hard disk for a few years and didn't change it, didn't have it plugged in, you would experience something called bit rot, which is effectively where the bits either degrade so much that they flip from a 1 to a 0. Basically, databases are designed to prevent against such things for your benefit. Again, you don't have to know how it works, you just have to know it's there. So, we come on to some incredibly useful but also occasionally complicated things. Again, as with the ACID principles, you don't have to know how this is implemented exactly. Many people have probably done about 20 PhDs on it, but all you do need to know is how to use them. And I would say if you're ever doing any work on a database in a company, that one of the first things they will do is to get you using transactions, because it adds an extra layer of protection against user error, which, let's face it, it happens. What transactions do is they allow different database users to put their operations into a sandbox, effectively, as I said, that little isolated bubble. They're incredibly useful, and I would say that any time that you start to type, update, or insert, or delete, you take a step back and you put it into a transaction. Even better if creating transactions is habit. The reason for doing this is that not only do they keep what you're doing separate from other people, they give you an undo button. So if, as I said, you run that giant update statement and you forget to put the where on it, you can roll that transaction back and the data will be unmodified, essentially. So it, as I said, gives you that extra protection against user error. Alongside that, also if you're not sure about what a query is going to do, if it's not going to behave, or if you're unsure about how a query is going to behave, you can put it in a transaction. It will run and complete. You can look at the results of the query, and then you can decide whether you want to save those results or get rid of them. Again, roll back. Transaction behavior varies from server to server. In Postgres, they're done fairly well. So you can have a transaction open, say that you've just updated a row in a table. You haven't saved or committed your transaction yet. It's still open. Someone else goes to modify that same table, except on a different row. They can do that because of the way that Postgres handles what are called locks. Databases, and this is why I said SQL Server is bad. Sorry if anyone likes SQL Server, that's how it is. The default scheme for locking in SQL Server occurs at a table level, which means that if you have a transaction in which you've done something to a table and someone else wants to come back and do something to that table, even just read from it, they can't because it's locked. Whereas with Postgres, it will lock on an individual row, so people are still free to do other things in that table. So let's just start showing some transactions now that you've heard me harping on about them for ages and ages. Okay. In Postgres, you can type begin, and that will start a transaction for you. Again, if you look at the documentation for transactions, you will see begin just in plain text, but you will see the word transaction in square brackets. Technically speaking, the entire command is create transaction. Or sorry, begin transaction. However, as I said, transaction is optional. The way they work in Postgres is that each connection to a database is only allowed to have one transaction open at a time. You cannot nest them. So if I run begin transaction now, I've just opened a transaction. So anything I do from this point onwards until I commit or roll back is going to be captured within this transaction. If I try and run that again, it's going to complain at me. There you go. So I've asked it to open another transaction, but it said, sorry, can't, and just ignored it. The transaction is still open, however, we've reached our maximum, only one at a time. So now we can, until we do a commit or a rollback, anything that we do in this query window is going to be separated from other data. So, say I was feeling particularly malicious, once this is finished typing, I want to delete all records from our open table. Oh wait, wrong database, sorry.
Transaction with a logging system and a query system, or what?
As in, will it record what queries have occurred? I'm not sure, to be honest. I would search Google. I would hope that it was possible to record all queries run by users. I have a feeling that that's not default behavior, though.
So what's the purpose of using this, like, to act as a middleman?
It's effectively to give you some security over if you make a mistake. So what I'm going to demonstrate now, actually, is I'm going to delete everything from our customer table, and that's going to succeed. There you go, 4 rows gone. So if you select from the customer table, you'll see it's empty. Again, all of the modifications to the database that happen in a transaction remain temporary until you hit commit. So running the query in the same window that we did the operation, so select after the delete, you can see that it's empty. But, and I'm hoping that this is going to pull through, if we look again at customer, go back to this query here, this is a different connection, and this is different from the connection in which we opened the transaction. So, one of two things is about to happen. Either this query isn't going to complete at all, and it will wait and wait and wait until the transaction is committed, or rolled back, or we're going to see all of our records in the customer table. I'm not a betting man. There you go. So in the transaction previously, we deleted everything in that table. But in this different connection, which is completely separate, our data is still there. And it will still be there until we commit that transaction. So I'm not feeling particularly mean, and I don't want to waste my time, so I'm going to roll that back. Again, select text and run. Just runs just what you selected. So our transaction's now rolled back. If we run that same check query, we're going to see all of our data still in the table because we undid what we did. And that is what transactions do. They prevent, well, their practical purpose is to prevent silly mistakes like that. They are incredibly useful, and I would strongly encourage you to use them on a daily basis.
How do you make it permanent?
How do you make it permanent?
Yeah, like how would you delete that?
Commit.
Just commit?
Yep. You've got commit or commit transaction. I'm lazy, so commit for short. And that's essentially all you need to do. Your workflow starts with begin transaction. Doesn't matter then what you do. Nothing will happen permanently to the database until you run commit. If you run rollback, your effects are reversed.
Okay.
So whereas before I said if you hit stop while the query is running, it will stop and undo. But the difference being here is that you can undo after the query has finished. Do you want me to explain it slightly differently?
So if you commit to deleting customer right now,
Yep.
you'll just do commit, yeah, or commit rollback.
Tell you what, let's run that. Delete everything from the customer table
Right, okay.
and commit it. Bink.
Oh, I get confused because you're doing selective test.
Sorry.
I thought rollback was in it. I was like,
No. Whenever you select, when you select text and press run, it's only the selected text that gets run. Like here. So if I didn't select the text here, it's going to complain at that second select statement because this doesn't end in a semicolon. Watch. Explosion. So now that that transaction has been committed, if we try and select from customer, that table's going to be empty. Ta-da. No records. None.
so if you do that while you're using a transaction, and then you finish the transaction, is that it permanently gone?
Yep.
So you're dead
If
to that point?
Yeah, if you make a mistake and you've committed the transaction, what you do is you go to your local supermarket, you get a crate of beer and some chocolate, and you take it to your database administrator and say, please, can you restore a backup? Because that's effectively your next option. Backups, we will cover backups much, much later on. They are a thing. But effectively, if you commit the transaction and you don't roll it back, you've got some groveling to do. Very quickly, while we have some time, did everyone get a chance to put their details down on that sheet for me? Yep. Excellent. So what will happen is you guys will receive an email to your university address that will contain setup instructions for the sandbox and your user that you're going to connect to the database as. Each user is going to have their own individual database, which they can create tables in, so you're going to own that database and be able to do all of those sorts of administrative operations. You'll also get read-only access to certain databases which we're going to use for reporting queries. So we're going to start writing some big, chunky, intensive queries so that you can get to grips with how to extract meaningful data, meaningful information from purely data. And I think that's basically us out of time. All right, thanks for coming, folks. I will see you next week.